Hey, everybody. Thanks for having me today. I've done this a couple rounds, so I'll either be super fast through it all or like running out of time. I'll try to mitigate here. As Allison said, my name's Elijah Wiegmann. I founded Base Design Studio almost 10 years ago at this point. Previous to that, I was the design director at Four Moms, the Pittsburgh-based robotics company. We had quite a staff of roboticists, engineers, software, and developed a whole range of products that you see there. And then before that, I was at Michael Graves Design Group, which is a product development consultancy known mainly for its architecture, like postmodern architecture, that then leveraged itself into all of the products at Target, in the 2000s and stuff: toasters, blenders, mops, brooms, buckets, housewares. So that's where I really kind of cut my teeth and learned about production and design from just having an idea to like, how do you actually make this? So that's really the point of my talk today, is getting design thinking. And that's not necessarily, like, I'm an industrial designer, product design. So that's kind of the lens I look at things through. But at the same time, this can be used for software, UI, UX, app development, even business strategy, or, research development. Like, design thinking goes into all this, and just using some of the methods I'm going to go over today really kind of, they give you a really good like guidebook, or if you're kind of stuck on something, kind of flipping through this really does help to trigger, like, all right, let's try this exercise with it. So design thinking is all about that uncertainty in your head. Like, creating a company or a product or a service is a huge, messy, complicated thing. Like, if you've done it before, or you're currently in the middle of it, that it's just, there's 50 things to do all at once, and which one to do first. Design thinking helps you kind of research that, test what you're doing, and then start developing solutions. So it's really good if you're feeling overwhelmed, or like there's just too many plates spinning right at one time, to know kind of where you should focus your energies. Designers, like with the capital D, the black turtleneck designers, like Ambiguity. We get comfortable with questions and not knowing and uncertainties, right? Which is a little different than, maybe a typical business model, or engineer might want the answer to this problem. Designers tend to really like that ambiguity. We got a lot of Post-it notes up on the wall about, like, what could we do? What are the possibilities? We're the sensitive artists, we're kind of like out there a little bit. Blues aren't the correct shade of blue, and we just ask questions like, what if it wasn't that? What if it was something completely different? Get it out of here. We're constantly asking, does it have to be like that? Why couldn't it be like this? And it might be ridiculous to ask that question, but it is. We do tend to ask those questions where the people in the room going like, why is it like that? But we're also what I'd call, the canaries in the coal mine, in terms of ideas, models, figuring out where things are going to break, or what humans are attuned to. As someone with an idea or a venture, this is the part where, like, you get sensitive too. Have you actually tested this idea? Designers are always asking, like, are your costs in line? What is this thing made of? Does it work? And one of the hardest ones that we're constantly asking startup entrepreneurs who are coming to us with our services is, like, does anybody want this? Like, what is your audience? It's great if it's an idea that you're obsessed with, but does anybody want it? So as part of that, you need the process then to explore whether anybody wants this, or is it strong enough, or can we make it cheap enough, or how fast can we deliver this? Which looks like this. This is pretty standard. If you have any interest in product development or design thinking research, you probably know this already, but the first step is empathizing. So really developing a deep understanding of the problem. Then you want to define that problem. You want to you want to say what you're trying to solve, or what are we looking for here? And then you ideate on solutions, right? A lot of people typically jump right to like ideating. Maybe this, maybe that, maybe this, when they haven't asked themselves the question of what are we actually solving for? Is it to get this robot as light as possible or as strong as possible? Without knowing what problem you're solving, you can't really do that. So after ideation, you prototype it. So you get a couple good ideas on the whiteboard or the Post-it notes, and you start prototyping. And then the real thing is like to test it. A lot of the time, again, people will prototype a solution, go like, yeah, that kind of worked, cool. And that's it, instead of testing it, breaking it, and going back to that prototyping stage. So the first stage of questioning is really asking, the question, but, what if it was like this? What are we trying to solve for? If this is going to cost us, $50,000 in tooling, how are we going to amortize that? And what's our run up to that? Whatever that problem solving is, right? You want to come up with that question and ask that question. Then you want to test it really quickly. Yeah.
Could you dig into a little bit more about the finding the right problem? Because
totally.
you mentioned, designers like the ambiguity, but the problem can't be ambiguous.
That's right. I mean, later on in the talk, I talk all about design loves constraints as well, right? So a lot of the time to find that like what if problem or the question of it is you want to look at your constraints. If you have a ton of liquid money in the bank, then you're not worried about the cost of tooling. You're more worried about the time it'll take, or the, dispersing the product, or how are you delivering it, right? So you want to look at the constraints that you're facing, whether it's time, money, talent, whatever that could be. What are those impediments to your business being successful, right? So later on, I'll talk a little bit about like how we work with constraints and test that, or do that. Test quickly, like these are just to show, like, this is the famous OXO, ergonomic hand grip. It's dumb at this point, 25 years old, but it shows like just get it in people's hands and make multiples. That's the important thing from that. Iterate, right? This is just like lamp sketch work and stuff, but it's iterating. Just keep flowing. This is the part of the funnel that you want to expand. Then once you've expanded that funnel, you pick it based on constraints, based on kind of what you're trying to solve for, and you focus in on a couple key ideas, right? So these are some helpful exercises to develop those questions, those hypotheses, like what are we trying to do here? I think a lot of the time, especially in a startup with a big picture idea, like I said, there's a lot going on. So you even have a hard time kind of steering towards a solution. When you wake up in the morning and you open your laptop, like what's the first email you're sending? What's the most important thing to get to? There's a couple different, these are just different exercises, right? So you can storyboard problems, whether it's literally drawing them or writing down the scenario, maybe your customer or your consumer's facing. Making connection. My favorites that makes me think of, which is, it's slightly internal thinking, but when somebody says an idea, you go, oh, that idea is stupid, but that makes me think of, right? Like it's that process of additive. It's a little bit like improv or something. But these are all different methods. The link down there will take you to a really deep explanation of some of those, but just to go through them. Connections, right? Like you have the possibility to, ask yourself even ridiculous things. Like I said, designers like the ambiguity, but what does happen if we take a light and add banana to it? Banana light, but does that trigger anything? Does that give you an idea, right? It's the famous like Steve Jobs original iPhone of like, it's a breakthrough internet device. It's an MP3 player. It's a digital assist, and it's combining, asking yourself so start looking at the connections between what you're doing. That makes me think of, and like I said, this is what it looks like in my head, or when you're sitting around a table with your your clients or your founders, your teammates, or whoever that is, there's a lot of dead ends to these trees, right? They just branch out, and it's okay for them to branch at this point. When you're asking questions, you just want to be generating. It's a building process, right? So you're building this network of all these little mental connections, or, oh, you said that those wheels, wouldn't roll over sand. That makes me think of these balloon tires on this other thing that would roll on sand. It's this additive process. Wishing is really good. It feels totally unhelpful and counterintuitive. If you're sitting around the table with 4 people and you go, I just wish it was lighter. I just wish it was easier to use. I just wish the damn toaster would show me how toasted the bread is before it, right? And everybody's like, I know, we all wish that. But that wish is the thing then you can action on and start testing and iterating, right? So really, like, as much as it's like unhelpful to listen to, wishing is really good. So really, it's all about then testing all of those things quickly, right? So you've ideated, you sat around, you've kind of stared at the wall, you've brought up a lot of interesting ideas or dead ends or connections, and you're just like, what is this? The important part of that is to then take each of those and start attacking them by testing quickly. It's the same type of thinking in agile product development or Scrum, or any of that, where you put a task out there and then you test quickly and iterate on it, right? So it's all about that kind of turnaround time. The more bites at the apple you get each of those rounds, it's going to get better and better. Iterating. So it's a little bit different than testing quickly. It's subtle here, but the difference between iterating and testing quickly is iterating is taking that idea and trying 4 different versions of it, like tweaking the wings, trying a new seat, trying a different, all-nighter product, sorry, but, like trying a different button color, like highlighting something on the interface, maybe. Like, iterating is refining that process, whittling it down, whereas testing is about a wide range of ideas. Yeah.
An example of like how to not take too long to test when you're just trying to figure out what's the better problem to solve, like what's not.
Totally. Again, that the only metric any of us have for making choices, like the CEO can just level set the organization. We're going to focus on this, but that's completely arbitrary, right? What should be guiding your process are the constraints that you're acting on, right? So when you look at your company or your project or your, like, let's say we want to develop this app, and right now it's an idea to deliver food through, your phone. What are the constraints that you're facing that could be a limiting factor? So, well, maybe restaurants don't want to sign on. How do we test that quickly, right? Maybe people won't adopt it. They think it's too expensive. You can test that quickly. You want to be testing all of that stuff, but re-delivering in a day, in 5 days, like, you want to cap that. So you come back to that process with some answers of where you've started testing. Does that make sense?
Using like polling / collecting data.
Oh, so you're getting really like specific about that. What I mean is, a lot of the time people leave like a stand up or something, and they say, hey, I was going to check the voltages that we're getting from this battery, and I'll let you guys know, like next meeting. They come back and they're like, oh my God, those voltages are insane. We can't, we're going to drain the battery in 2 seconds. That's a test, like that's the type of testing. There's tons of like very specific voice of consumer or polling or, kind of, I am talking a little bit about the internal testing. If you're sitting around the table with your founders or your partners or your clients, that internal testing tends to shake itself out pretty quickly, because it's a personal one-on-one basis. If you're asking a question if you're an engineer and a businessman, you have two different ways of looking at it. You have the same problem, but you can talk about it and get to something pretty quickly. So this is, they're going to pick one of those kids and one's going to be last, right? Like this is the point where you start focusing your ideas. And this is kind of what it feels like when you're sitting around that table, to your point, and you've started testing a range of ideas. There is a time to start cutting, to start picking the best ideas. Or this is actually a good example of that. Just like picking teams, start with your first priority, or start with like the best player, right? And you're on the team. And then the second one. And if you got time, get to the third one. And if you've got more time to test or more, ability, go to the four, you can kind of play that out as long as you possibly need to, but you do want to start like focusing in on something. A lot of people, it's a very hard process to jump from testing and iterating to saying like, all right, but now we're going down this tree here. See, this is how you know any of it. My favorite designer, Charles and Ray Eames, husband and wife team back in the 40s and 50s, mainly famous for furniture, but all sorts of fun stuff. Is the best quote he's ever done. I'll let you read it. But it's all about, it's counterintuitive that a designer would like constraints, but that's the only framework we have, right? Like if it was just about what was cool or what was really flashy or what functioned the best, well, you could build, a spaceship, or you could build, a Tesla, but you need to know the constraints that you're working with. What are we trying to achieve? Working within those based on price, size, strength, that's exactly your metric system then. And you can literally assign value to it, like one of those star graphs of, okay, what is our number 5 priority? All right, what's number 4? Once you have that value system laid out of your decision-making, your constraints, you'd be amazed at how quickly a lot of those problems start either falling by the wayside or make themselves known. So you want to study the constraints. The second part of that is you want to tell everybody on your team, right? Because the constraints to the mechanical engineer are different than the electrical engineer. They're worried about two different things, right? So developing your vocabulary of constraints and all kind of coming to a consensus and an agreement on what those constraints are. If everybody knows that the key constraint is making this the lightest it possibly can be, then those metrics get easier to solve as a team, right? If somebody's trying to make it the lightest ever, and this guy's trying to make it hold up to, 20,000 cycles, they're diversely opposed, and they're going to come back with two different solutions, and you don't have any way to judge them other than like, oh, Fred's nicer, so Fred's concept wins. It's not that, you want to filter it through that constraint system. To do that, you start prototyping. So you've got your problem, you've kind of iterated an idea, you know what you're trying to solve with it. This interface needs to be easier to use, it needs to be quicker to respond. So then you start prototyping. You start kind of building tiny little pieces of this, the little Lego blocks, or each component of that problem, and then you start sorting those. Well, we've already got the battery part of this, we've already figured out, right? That's easy. Put that in the blue bucket. This red one, this is a hard one because, it keeps breaking in half, whatever that is, right? But that's how you start organizing and filtering. What are the problems that you've solved? What do we already know? And what's still out there? This is again, this is just lives in my head. Tons of startups, people live in this graph, right? Tons of ideas. That red line is like the go-to-market product, or the time when you feel that it's ready to go. And you've got branches all headed towards that. but man, it's starting to be very divergent. But when you hit that red line, that's when you focus. That's when you're picking your dodgeball team and you start doing this. This is prototyping. This is testing. It's this rapidly tightening spiral of test, iterate, develop until you've come up with like the tightest possible. If you can end at this like one laser beam of what this product is or this service or this offering, the tighter you can get that beam, the more it's going to resonate with people, customers, consumers, you know, whoever's using this device, like laser focus. Part of the testing and the building and like why you're prototyping ideas, it's like I said, it's arbitrary, right? So when we were talking earlier, is this to sell clients an idea, or is this to like make sure that the wireframe is working and the connections are working? So when you're ready to prototype something and we want to figure out, I'll just keep going to lightness for some reason today. How light can we possibly make this? Is this for the retailers who are going to be selling the product to be able to point to it on the shelf and go like, look how light this is? Or is this for a proof of concept to know that the actual carbon fiber at this thin of a ratio is going to hold? Those are two different prototypes, right? High fidelity, low fidelity, complete and partial, right? The reason you want to ask yourself this, a lot of people bog down in really high fidelity, really complete things that are meant for getting in front of like final end users demoing the product. A lot of the time, that's how you waste tens of thousands of dollars on a foam model that really doesn't tell you anything that you didn't already know, and you haven't tested it. Sometimes if you just staple two 2x4s together, that gets you the answer, and that's low fidelity and partial, right? That's just testing the joint, not the entire thing. So you want to ask yourself, like, who's the audience here? This is not where, you know, this is part of that testing the entire thing or part of it. This is not where you're figuring out how to make the mold. This is a mold, by the way, like a crazy, there's 5 actions in this thing. So, but this is not the stage where you're figuring out how to make the entire thing. You don't need to do that. Make a model of the wheel that has to roll, the little one wheel, and then say, all right, we replicate that 5 times and put that on the base. I'm just looking at chairs here, but you get the point. Break it off into pieces. Don't worry about how the whole process is made, what materials, all of that. I really can't recommend this enough, like now this is physical product design, but it gives you a really great sense. Go and download these little cards. They're free. They are so good in, when I say prototyping or testing or development, these are all the different ways to do that, right? And they're subcategorized into, is it the concept stage, development stage, the embodiment or detail stage? It's such a good cross-reference, but like an idea sketch, that's the kind of thing that, you know, the company frames on the napkin once you've made 1 billion, you know, units and it's everybody in the world uses it. It's the little napkin sketch, right? But it can go all the way to, you know, I don't draw well. Okay, well, do a memory sketch, you know, like just write words that point to other words. It folds now. And then after it folds, it goes in the trunk. And then it, information sketches, like this is where kind of designers are coming in with like a sketch rendering for more emotion, right? These are 2 different sketch styles, and they're achieving 2 different tasks, right? You want to understand like how we're going to put this together, or do you want to feel like, oh, that product's going to be sporty or futuristic? It just keeps going, you know, but like you get the idea. And as it goes down, it becomes more and more fully fleshed out. So you're getting closer to like physical models now. You're getting cardboard models that are mocked up to like test a joint in something. Functional models. When you start getting into appearance models, like I said, that's where you think about that quadrant, and you really want to ask yourself, like, do we need a foam helmet? You know, like just looking like the helmet, or is it more important to test the helmet and try to break it? Sometimes you do. Like if you're in a room with venture capitalists, you need the appearance model. You need to make it look badass. It's sitting there on the table. They're like, man, that's great. And you're like, it doesn't work. Don't touch it. It'll fall apart. But it looks good. And that's the point of it, is to sell the idea, right? Same deal, just as we go, I don't want to keep hammering this, but finally, eventually you can see that you're literally starting to get that final hardware into a tooling component, into a pre-production component. That's where you can start really starting those user testing. But this deck of cards, or this PDF, if you go through it, it gives you a really good sense for a gut check of like, where are we actually? Are we testing the prototype bike right now? Are we actually like putting some Play-Doh together and figuring out how those two pieces go? Other ways to test: drawing, right? I mentioned it. You can draw mind maps, flowcharts. This is drawing, I can draw a hell of a sketch, but half of the time my desk looks like this, because it's more about the, you can draw it with whatever curve you want or anything, but even if you're not an artist, you can sketch it. Physical, this applies directly to engineering, product design, mechanics, but build it, right? The first best thing to do is go off the shelf. A lot of people immediately start trying to 3D print the thing, do the CAD, go to Home Depot, buy a bunch of screws, or, like for one of my clients, like literally on my way home, I'm going to go to Lowe's and buy like 4 tool belts and cut them apart, because they already exist. We're just like looking at a mod, right? So off the shelf. Buy things that are similar and take them apart. I skipped ahead. Cardboard. This is like art school, design school 101, but I just don't have a good sense of, like to a designer, this is like, well, yeah, of course. But really, like if you're designing an ATM machine, build the ATM machine in cardboard and walk up to it and go, oh God, that looks too tall or too wide, or people aren't going to use this, whatever that is. Like get in there and start hacking. From there, you can really start into like this. This is like super basic. This is definitely product design, industrial design. But the idea is just start loose, even if it's like crayons and, like Play-Doh, that at least gets you into something that you can hold. And the next thing of that is like handing that to somebody, even if it's a lump of Play-Doh, but it's the right size. They go, ooh, that does feel right. Or, oh my God, that's awful. Right? I mean, they're still designing cars in clay. We've got, yeah, go for it.
I would say the development of AI simulations, the ability to do that faster without having to actually build it yourself, because that takes longer.
Totally.
And how much we trust that has affected this process.
I think it's affected it immensely. I think it is only, there's goods and bads about it, right? Like, so you can get 100% results. Like I trust all of it explicitly, but I also trust the mechanical engineer that told me that this arm is going to snap off this thing. It's not strong enough, right?
And I just follow up on how do you weigh of okay, I trust this more than time
versus time.
Like doing something well and taking longer versus doing it well enough and much less.
I don't have a great answer for that, but I would think that you'd want to be filtering it through your constraints. What are you hoping to learn? Are you hoping to cast a really wide net and get tons of data about it? Cool. AI or generative solutions are going to be awesome for that. Are you looking for the edge cases in every scenario? Cool. That's probably great for that. Are you looking for what the 98-year-old woman trying to open the pill bottle is going to do? Probably grab a 98-year-old woman and hand her a pill bottle. So those are those solutions in terms of you can run AI on it. Sure, it'll give you something, but it's probably better to hand her, So, but that was almost my point here, right? You guys could all design a car body right now using AI, some of the software, you don't even have to drag your mouse. You can talk about it now. You can reference other cars. Chat GPT, make this look like a Nissan Juke mixed with a city bus. It'll give you results, like you'll get there, right? But they still make cars in clay. And the reason is like, you can't walk up to that yet and touch it and see the way the light hits and, like experience it. Humans, no matter how good we get, until we're all in our little matrix tubes and it's all coming in through the feed, we are beholden to the environment, right? Like the temperature in the room, the light, how you feel that day, what you ate for lunch. Like we're emotional, creatures. Like you still need things. It's just when and where that hits in the process. That was a little left field, but a good question. Like that is like, as methodologies increase, I think once again, the rock solid part of this is just filtering it through your constraints. Just keep doing that. Keep asking yourself, what are we trying to learn? What's the most important part? For this, like this is literally handle shape. So at some point, you could, I could render you 50 of those out of SolidWorks and, 3D print them or foam them. But until, 5 people pick that up, you're not going to have that sense. And it's different. The buying officer at Lowe's picking it up compared to testing, 30 homeowners who are going to be using it to trim the bushes. Those are 2 different audiences. That back to that kind of plus minus chart. The one guy who's going to decide that he's going to buy 1 million units of this, or is this a good ergonomic solution for, the average household consumer? 2 different audiences. Soft goods prototyping. This is near and dear to me. Like, I love soft goods because they're real. They're like, when I sew something as a prototype for a client, it's typically the real material sewn how it would be made. It's not apologizing for a 3D print or, oh, this is made out of clay or it's not quite strong enough yet. Prototyping with soft goods, even paper and tape, like making something, it gets to be really quick, really fast because you're literally using those materials and you're making that production method. Next level prototyping is like, this is where you're getting into design agency stuff, right? So this is the SolidWorks CAD or 3D printing. It just really, like I said, you really want to be thinking 50 hours and like a CAD modeler, like specifically that salary and that time frame, is this helping you? If it is, great, but if it's just to make the a lot of people jump in and start extruding stuff. Now I'm making it, you're like, not sure it's the thing you're after. Computer renderings, so photorealistic, you can tell a ton by this, and it's so fast and lightweight comparatively, right? Like instead of making that bench model, you can say like, this is matte plastic here, there's a little grip, we're going to light this button up when it's doing something wrong or whatever that is. This is a great place early stage where you can start exploring things like the colors, the materials, where are we putting the logos, how are we treating the surfaces. Eventually you got to jump into 3D and you start 3D printing. The whole point of this guy, again, like this little block actually came out and we experimented with where we were moving that button. So we had, 6 of these little things that would move the button over here or up there, or a square button or a pill-shaped button. That's the type of testing you want to ask yourself, like, what are we trying to achieve? We know that we're stuck or frozen on this device. That's where we're at. But wouldn't it be better if the button was here or there? This is that thing that like, that's $15,000 just sitting there. 3D print, sanded, primed, painted. You need to arrive at that, but you need to arrive at that when that's the thing you need, not when, when the internal team's working on it, that other one's probably just as good. It's not as sexy, but it's just as good. But when you're handing this thing to the person who's going to be writing the order for, like I said, the 100,000 units, that one's worth every penny that you spend, but late in the process, right? There's an idea of invisible prototypes, which are things like acting it out. This is really great for services, for UI, UX. If you're, let's use the ATM interface, software, act it out, like Oh, I'm opening the door. Oh, that's a pain in the ass. That's in the way. Okay. You know, like you get there really quick. It's invisible. It's like I said, it's improv. This is a really good one. Again, everything, I don't know if you can tell, but it's all about spiraling down. So this is 7-14-28, which is kind of like from, we picked it up from the robotics world. Make a peanut butter sandwich in 7 steps. Get the bread, put the peanut butter on the sandwich, put the jelly on, put it together, 7 steps. Okay, now if I ask you for 14 steps to make the same peanut butter and jelly sandwich, you get specific, right? If I ask you for double that, 28 steps to make peanut butter and jelly sandwich, you're like, what in the heck you're talking about? Take twist tie off the bag. But that's where you learn those tiny little surprise and delight features that could completely change the project, right? Like those little invisible things of like, it is a pain in the butt to reach up and get the bread out of the cabinet. What if we didn't make a sandwich? We made a cabinet where it was down here, whatever that is, right? But those are those little things, those insights. It's a good way to get there. Always take your process and just run it out to ridiculous levels. Scale is really important. Little buildings, all the way up to like, we're designing a kitchen. Well, design it full scale, like live in it, feel how it is. Don't put it in the screen if you're going to be walking around with it. Cars, again, like tape on a wall. This is not going to tooling. They're not going to cut any, like steel molds off of this. But it sure is important to look at how that lives in the real world that we all live in. Human scale, right? This battery is too close for the user. And then get it into people's hands. That's the other part of that scale thing, right? So these people all know how to break stuff. They'll mess up your app. They'll download it wrong. They'll, like turn it upside down, put it in people's hands and let them break your idea, right? Let them test it. But you got to have those hard conversations, right? When you hand it to them, you don't get to say, like, and this is the cap. And so you want to twist this counterclockwise and you can't do that. You have to like have the hard conversations like, oh my God, all 4 people had the thing upside down. I think we've got a problem and we need to like figure this out, right? From there, like talk to the vendor. Like this is getting more realistic, but if you're, again, I'll just stick with physical product, but if you're building something, after I make my beautiful model, and we've got 3D CAD, I know how to make stuff, but I'm not a tooling vendor, so like you want to talk to those experts in how this idea is going to be executed, whether it is the deployment, delivery services, whatever that is, talk to the people who are going to be that next level down from you. These guys know how to make stuff, right? So even though they're not designing stuff at a production facility, I'll bet they have a bunch of good ideas about how thin the thing should be or how they could do it. There's just 2 absolutes of prototypes, I think, and there's no set number. There's no like guidebook or rule book for how you test it or how you do it, but it's definitely more than one. You really want to like keep doing it. The more you do it, the better. Yeah, there you go. I skipped ahead a little bit. Each prototype you do is going to teach you something, right? Usually each prototype is going to help make your design better. It's really rare that you build something, kind of see something, and then it's completely useless. You've learned something. You're like, that was the wrong way to go or the right way. So really it's all about building. And then in the time left, it looks like I've got about 15 minutes here. This is like my little guidebook. This is just making things real from a very specific, like designer's eye perspective. Things we talk about, like when we're educating, CEOs of the company about like what to look for, how to, like what we're doing. Alignment. This thing's awful. Like the seam lines on this are completely arbitrary. Nothing lines up, right? It's disruptive to the eye. Line things up, right? Just clean it up. Look at one line. If it's off like that, ask yourself, wouldn't it be better if they lined up? Align it. Yeah, so this, I previously had another car example that had much cleaner lines on it. You can tell the way they designed this Lincoln, and I'm sorry if anybody drives this, but they designed the form, the skin of it. And then production engineering hacked this line into there, right? They're like, we need a trunk. Trunk, there's where the trunk is. Wouldn't that be better if it flowed through here into that? Or, like look at where the bumper lines up, where you parted the bumper from the rear quarter panel. Wouldn't that be better if it lined up with the line on the door a little bit so that we were talking clean?
Functionally, I mean, if it affects function, then not like, does it matter where if someone has to see a line?
It absolutely matters. The reason it matters, and it is completely arbitrary, like that's a little tongue in cheek, the designer of like, yes, of course it matters. It is because people have a natural understanding of, if I gave you a 2-inch shelf and a 2-inch block in your hand, your natural like human instinct would be to line that up on that shelf. You would, like it's a rare person that you would take that block and sit it on the shelf like that. You'd be like, oh, look, it fits. That's so nice. It gives you a sense of peace. It's what Apple has done all of the time. Removing those buttons, the buttons on, phones, removing those makes it a cleaner, more tranquil experience.
It's also can be less function.
I'm not talking about sacrificing function for that. There are many examples of cars with beautiful lines and magical ways that trunk break happens. Yeah, I mean, it is not sacrificing function. I'm not doing this or that. What I'm offering is, if you can go up to an edge with something and get rid of, that visual clutter or that material break, not only is it probably more satisfying for, the end user, it's probably actually even a little better for production material stack up. Instead of having a bezel, it's easier if we just go glass edge to edge, right? Like that's just, it's what things have evolved to. If you look at a refrigerator from, 1950, lines and curves all over it, chrome inset handles, big zinc plated, big badge on the front. Look at a refrigerator now, it's for production because it's cheaper to make one sheet of steel. It's also more intuitive. Some don't even have handles. They've got a little ledge, because do you need a handle? Does it function any better? If the Cove handle functions just as well as a bolted on handle, guess which one's a lot cheaper now to make? It's people's natural intuition. One of the best ones is like, there's a chair and they put 2 tiny little nubs under the front seat pad, and you never even see them. But the minute you go to scoot your chair up, like under the desk, you feel those like 2 little handhold bumps, and you're like, wow, somebody thought about this. It's that surprise and delight feature that, like that people react to. Beauty gaps. This is another thing, like a very real construction constraint. Look at every car and they have different sizes of beauty gaps, and you can tell how expensive a car is by how well they line up, how precise they are, like whether they are getting bigger or smaller, whatever that is. It's a great way to like celebrate those details, right? So this is a case design with a top shell and a bottom shell. We had these buttons. The company is a little startup. They can't afford to even do the secondary mold for the buttons. All right, shit, how do we do this? So we incorporated a beauty gap here. We got rid of the buttons. People can still use these little, it's for setting and resetting the system. So those buttons are fine. And the plastic parts aren't expected to fit up into this perfectly zero tolerance from their like $5,000. We could barely afford the mold maker, so here it is. You build in that redundancy, right? And it looks like it's meaningful. Pick one thing and celebrate it. Like you could have the rest of the product just matte black, but if you call attention to one detail, that's something for people to assign value to, interaction, feeling. This is the back. Isn't that isn't that better looking? Also, it's less metal. There's no metal here other than internal, but like, this is just glass. So the other car had a glass rear window. This has a glass rear window, but it doesn't have traditional B pillars after the tail, right? Like, so it's just cleaning things up, combining pieces, looking at it. Everybody here is probably too young, but like laptops used to have bezels, like plastic bezels. And then, like Apple or some designer, I don't know who did it first, but somebody went, make it glass all the way. Isn't that better? Oh, it's clean. I don't have that shitty little bezel collecting dust and everything else. Like try to combine pieces. Just look at what you can combine. People love multiple materials. One of the things I didn't mention in my soft goods portion was, 95% of our world is fabric. Look around, each of these chairs is upholstered. You're all wearing clothes. All of you touched a backpack or a bag, right? Try different materials. It's not all injection molded plastic. It's not all extruded aluminum. See what your design might be if you could make it out of something that feels great to the touch or something that can fold or pick up the light in a cool way. Just exploring that, That speaker looks pretty cool. It's not a plastic casing or a stamped metal speaker grill. So not only does it look different, but the company is selling a piece of felt on the top of it, right? Like they don't even have to mold the thing, like the outer cosmetic casing. That's $20,000 to $30,000 worth of tooling on that speaker that is now a sewn piece of felt. You could make it recycled bamboo, so it's more sustainable than shooting a plastic piece, right? There are arguments for all of it, but just explore it. Just think about use soft goods, try something like that. This goes to my scale part. Like, this is purely aesthetic, but play with scale, right? These are two strollers. And you worry a lot about pinch points with strollers. Like when you close them, you're worried about like two pieces coming together. With something small like that, you start incorporating the more stack up of materials, the fact that you have this bolt, which is, like that's as thin as you can get that bolt to the structure. You build out from there, you get plastic, this goes into the sleeve, you got a rivet. There's so many parts there that before you know it, you're into what I call part stack up, right? You start getting thicker, heavier, and more stuff, and more complex, and parts don't fit right and they creak. If you plan it and you design for it, maybe you don't even need the screws. You don't need to make the tube fit into it. This just took a little bit more thinking than this joint, but it was because they thought, well, let's just blow that up to like where it doesn't create a pinch point when it closes, right? It's offsetting that. But don't assume scale on something without at least trying it smaller or bigger, right? Like hitting the magic scale button. So that's it. I'm talked out. That was pretty much on cue, but they said one more time the process. Emphasize, define, ideate, prototype, test. That's it.
I'm an engineer, so.
I can tell.
Okay, so, but like, how much does budget constrain you? Just because, like, in an ideal world, yes, of course, you can meet the designers, like, needs and engineers' needs with enough money, but like, at some point, you have to cost-benefit analysis and figure out what's worth it, and also, like, how much does the design versus the function, how do consumers respond?
Absolutely.
Do that.
Yeah.
So like,
again, you're going like, so you're having the typical kind of like, I mean, we talked about this at Four Moms constantly. Very robotics, engineering, building like working, folding power things. And it was also very design forward, like the CEO that thought he was a little mini Steve Jobs and walk around, it's just no good. The design is awful, right? So like as the design director, like I'm in the middle of working with engineering and giving the CEO and the users like this beautiful, magical design. There's no just, it is not the same stack up all the time, right? I think it's contrary to think that adding good design thinking or good design initially immediately adds cost. It doesn't have to add cost. In fact, like with the soft goods prototype of the speaker, takes away cost.
I was saying, yeah, like depending on what the design is and what the engineer, what's required, and it's like, if it's a car versus a speaker.
Totally.
It matters a little more for a car than it is for speakers, like,
Yeah.
but then follow-up question about prototyping, like user prototyping.
Mhm.
Like when it gets to that like very defined stage and you can only make a limited amount because you're not really. As far as reaching an audience, like wouldn't you want to be able to give a prototype to a limited amount of people and how do you make sure that represents the audience that you're trying to go for?
Yeah, that totally. That is one of those jump off the cliff things. I got news for like you will never have enough pre-production prototypes to feel great about it. I guarantee it. You can have 10,000 out in the world and you'll wish that you had just had that extra 5,000 more to send out to the other audience. You know, like there reaches a point, and again, I think the important thing about a successful organization or process or company is asking themselves, you know, like, when do we feel good enough? There, you know, we had a saying that good enough isn't, awesome enough is, right? It's about pushing that until it was like awesome enough. It wasn't about it being the most awesomest or just good, but like if you could hit awesome enough, that's when you've got to like kind of cut bait and start making it. It's really hard to know when that is, but if you're trying to say we can only get 20 of these before the trade show, and I wish we could get more so that we could send them out to testers, whatever it is, you're never going to hit that number. Like that's a made up number in your head. Like it, you know.
How do you go about user interviews during this design process?
It really, really depends on what you want to hear or what you want to explore. Just another like little piece of for moms, you know, example. You're designing an infant tub, just a little tub, and you pour water in, it actually tells the temperature. So it's not too hot or too cold for the kiddo. And then the clean water is going in, and then the dirty water kind of flows out through this little drain system. So we're kind of regulating, like figuring out how big this hole is, how little that one, all this stuff. And we put it in front of the moms and everything. And they were like, I like that the rinse cup looks like a duck. And you're like, cool. But like, how do you feel about like the safety of it? Like, do you feel like it's going to keep your kiddo from being burnt? I don't know, but I like that it's a yellow duck cup and it looks like a duck, you know, like, thank you. That is not helpful, you know. Or like the other really, really famous one is like a CEO comes in, like the decision maker, whoever comes into the room and is just like, I don't like blue, you know, and you're like, okay, well, it's not really about it being blue or not, unless we're selling blue paint. Like we can change that, but like, let's talk about, do you like the way it works, the handle? So that's a long way just to say, think about what you want to be hearing or what you need to be hearing and point it in that direction, right? The reason we were getting the tub comments is it was not a directed focus group. We had not thought about it. We took the product, put it in a conference room, had a couple mothers in and had them talk. There was no guide. There was no guided. There was no kind of process leading. There was no exercise that it was based on. Maybe a questionnaire is better to do. Maybe whatever that is. But
Like follow up, like how do you do the guidance?
the guidance, that, dude, that's a whole, I mean, there are entire businesses you'll pay to do the guidance if you want to. You know, tongue in cheek, but there are like just testing places. Like you can literally pay a company hundreds of thousands of dollars. We want to know what customers think about the blue of this label. Go. And they know how to do it and they test it. With just a little bit of thinking and a little bit of thinking about what you want to learn and like critical thinking, you can probably come up with a set of questions or a way to do it. Also, with any of those exercises that I showed, like those are entire processes taught by courses or, you know, continuing education. You can go that route. It's all online, you know. How do you user test software? Or, you know, how do you user test self-driving cars? How do you, you know, like, it just takes a little critical thinking about like, what are you trying to learn? And then what would I feel if I was walking into this room and there was a white tub with a bright yellow cup on it? You'd probably be like, oh, let's take the cup out. There's an idea. Let take the cup out of the room. Now they'll just talk about the tub, you know, like, so it's just critical thinking about that. Yeah.
How long would you say the process is like on average for some products you work with? More like in the first stage, like the products that you-
It's everything. I mean, it's wild. There's some really simple stuff that should be in market that I've been working with the guy for 6 years, but it's because it's not, well, there's this other jar we got to accept, or there's this other thing, you know, super simple. Or there are things like super high-end robotic stuff that like has come to market in 8 months, like really aggressive timelines. They've had their vendors set up already. They've worked with partners. So there are some people that I can literally, you know, do the next round of CAD, and their vendor, who they don't have to like pick or go through the quantitative process or, you know, like go through a quoting process. Like they're just like, we always work with Kennametal. They're great. You send Kennametal the drawing, and before you know it, the hood of that thing is there on your desk, you know, like, yeah, we made a prototype for you guys. You're good business partners. So there's really no timeline. It's never as quick as you want it to be, you know. It's all about, I think, always looking 2 steps ahead, right? So when I'm in CAD developing the 3D of the thing, I'm already trying to think, what am I going to talk to the potential vendor about in terms of molding? And can I put it in here now? And you know what I mean? Like, to get that extra step, one less thing. Instead of arriving at somebody's door and going like, oh, what do you think? It's better to go in and say, like, I looked at it at like 0.5 mil thickness and 0.7. I think the 0.5 is a little too thin. What do you think? That's how you get quicker answers, that testing and constraints.
What do you think about the lines in the projector?
It's distracting, isn't it? Wouldn't it be better if it was a bigger screen or a clean screen? Allison, I think we need.
We need a.
No, but yeah, it's a very human response. That's the one designers get out of jail card is we're all humans, right? So like, sorry, it's proven people like warm things, soft things. There's, you know, it's very rare that somebody's like, I like it. It feels like sandpaper when, you know, like, not really. Yeah.
I was wondering if you could speak on like the design process for software products.
Totally.
Beyond just like UX.
Yeah, I mean, so when it gets deeper into that, that's where, you know, like our expertise is very much in the UI, the UX, like what's guiding the human to push the right button, or how are they going to look at a glance and know it's like the hamburger menu up top, right? Like that's like the most insane, like that's just training. That is trained people, right? That is not intuitive if you were to hand some new person that, but everybody knows it now, you know, like everybody knows, hey, hamburger menu up in the upper right, you know, like, you know. So all of this is applicable in the framework. I keep going back to it because it really is my only guideline, you know, like you can try all sorts of, like, I'm a designer, like I like a cardboard paper pattern. I like a fully printed out cool model. I like a prototyped UI that I can swish through that's fake, you know, it's just PDF slides linked and say, like, all of that works, but it really is like, it's all within that guideline of like, how do you want to test it, or what are you trying to achieve with it? You know, what is the step to get it in people's hands is my like last always question. Will people want this? And will people want it? Backspin. Is it too expensive? No, they like the cost is good. Is it too hard to use? They say it's hard to use. We got to make it easier to use. Okay, you kind of backfill it to look for ways to approach like any of those problems. Specifically, when you're talking about like, like software engineering and like kind of deeper level, like coding or like how you're compiling or whatever that is. That's where I'm like at the edge of the pool. That looks crazy, guys. Cool. It is cool. I'm glad you know it. Cool. Any other questions? All good? Nope.
So, during your kind of core moms or other parts of your career, what were sort of the either departments or people that were kind of the major roadblocks for you pushing your vision forward? You had a great idea for design, but this department was what were those?
I mean, every one of them, like literally like marketing, sales, the CEO just not liking blue, engineering, the more, we had a pretty strict policy about like setting up kingdoms, we called them of like, well, that's marketing's on floor 8 and they send us some emails over the fence and like, we either do them or don't, so like, if you don't set up those kingdoms, this is engineering, man. We're not doing any of that design stuff, like that's just not the way anybody wants to actually be in the process anyways, right? But everybody has their vested interest in the process and how they're looking at it, right? Marketing is looking at, marketing would spend crazy amount, more money than the product was going to make to talk about the damn product, to sell the product for more money than, you know what I mean? Like it was such a bad cycle, but that's how the business was run, or that was the priority of it, right? As the product designer, the industrial designers, I always worked with my team about it is not okay to walk into the room and be like, design says this is the blue we're going with. Like, you can't do that. But if you show up with like 15 different blues that first we looked really quick and cheap at these 15, we narrowed it down to these 8. Then we put these in front of a couple real life moms. Those moms said this and that. So then we took that, we tried it this way and that way and this way. And we really think that this. So now argue it, you know what I mean? Now say that you don't like blue, like it's just a much tougher thing. And it's not meant to be argumentative whatsoever. When we work with clients and we walk in the room and the engineers like lean in and they're like nodding their heads and they're excited to like take part in like cool looking design stuff, that's the best place to be. When you walk into a place and the engineer goes like this, you're like, ah, shit, here we go again. Okay, cool. But that's just the process of it. Yeah.